Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Higazi, and in this tutorial video, inshallah, we will discuss how to create this type of TMA heat exchanger, BEU TMA heat exchanger. As you can see here in this AutoCAD drawing, we have a bonnet part and a shell part, and inside here we have the tube bundle with appended tube. That's the BEU type heat exchanger. Okay, now let's start modeling of the bonnet with the tube sheet and discuss on the first part of this tutorial how to generate that. Okay, now let's open SEG software, and from new button, let's create a new project and give it a name. And from here, let's select the location of the project and select the module, which is the heat exchanger module. This module will give you the ability to create a tube sheet, expansion joints, many of different items of the heat exchanger. Okay, now let's select the tube sheet, let's select the equipment node from the SEG tree, and as mentioned on the first tutorial for the vertical vessel, you can define the information here. Regarding the position of the equipment, we will leave it as it is, as horizontal, because it's a horizontal heat exchanger, and we will leave the direction to be left to right. But if you take a look to the general arrangement here, the direction of the this heat exchanger starts from the right direction to the left direction. Okay, in SEG software, if you would like to generate U type of TMA heat exchanger, we are recommending make it from left to right. So that means you will start generating your equipment from left to right direction instead of right to left direction like this drawing. And in your drawing, you will look from the elevation view from the right view, and we could discuss that. Okay. Now let's keep everything as it is, and from here let's start creating the first element, which is an ellipsoidal head. So it will be right head. Okay, and for the right head, we will select the suitable type for this type of head. Now let's open this one, and if we take a look here, as you can see, it's a half of ellipse. It's not a head with crown and the knuckle radius. As mentioned here in this drawing, it's a half of ellipse. So we will select the same type here, which is ellipsoidal head. It's a half of ellipse, not a head with crown and knuckle radius. So let's select this type and define the inside diameter. As mentioned here in this drawing, it's 740. So it's 740, and the thickness is 18, straight flange 50, and the minimum thickness after forming is 15.5. And here's the head ratio. And here the material, we will keep it as it is, and we will click on save. Now let's add the second element, which is can one. Okay, and from here let's select shell element, and from here, as you can see, if we measure the length of this can from here to the straight flange is 455. So the inside diameter 740, the thickness is 18, and the orientation, if we take a look, the thickness is 18 here, and the orientation for welding line 1 and 3, it's on 300. So it's 300 and 455, and here's the gap, and let's click on save. Now we have another element, which is, let's start creating the assembly, and from here we have this flange, which is heat exchanger flange with a grooved raised face. Okay, it's not with a projected raised face, it's a grooved raised face. Now let's open the SEG again, and as you can see here, we have the first bonnet. And here in your drawing, you will use the right view to add the elevation view for this heat exchanger. Now let's add the designed flange. So from here, let's select designed flange and name it as F1. From here, select this flange. If you take a look to the image on the right hand side, the first type was integral welded neck with a raised face. As you can see, this raised face is a projected raised face, but actually we need a grooved raised face, which is the second type of the designed flange. Kindly take a look to the image on the right hand side, and from here let's define the dimensions of this flange. So the inside diameter is 740, and the end thickness of this one, which is the same thickness of the shell, which is 18 millimeters, and the neck thickness is 24. So we can take a look to this view here. So the end thickness is 10 millimeters, 18 millimeters, and the neck thickness is 24. Okay, and here's the neck length as per this drawing is 28. So it's 28, and the flange outside diameter is 950, and the flange thickness is 114. Okay, and the raised face thickness is 7 millimeters, and the raised face outside diameter is 793, and for the bolt circle diameter is 880, and the bolt hole diameter is 33 millimeters, and the number of bolts there is 36. And now let's save this flange, and let's check the flip option after creating this flange to check if the direction of the flange is correct or not. Okay. Now this flange will be generated, the direction of the flange in a correct way. So as you can see here, we have this flange direction is okay. Now let's add a pass partition, a gasket with a pass partition. So from here, let's select element, and from here, let's select gasket with pass partition and give it a name as G1. And from here, let's select the number of pass partitions. We have 2 passes, so we have a part here on the middle. So let's define the gasket inside diameter is 750. So let's check the drawing here. We have that value, which is the inside diameter of the gasket, and here the gasket thickness. It's as per this drawing, it's 5 millimeters. So we will define it as 5 millimeters, and the gasket width is 20 millimeters, which is the inside diameter, and here we have the outside diameter. The difference is 40 millimeters, so the divided by 2, so it will be 20 millimeters in each side. And here the gasket TB thickness, which is the thickness at the middle here, is 10 millimeters, and here the fillet as per this drawing is 10 millimeters, so we will make this value as 10, and the orientation is 0. And now let's click on save. Now let's add another part, which is the tube sheet. So from here, let's add a tube sheet. So select this item, which is tube sheet, and click add. And from here, let's select the type of the tube sheet. It's extended as a flange. So from here, let's select the second type, which is tube sheet gasketed with shell and channel, extended as a flange. And from here, let's define the outside diameter of this tube sheet. It's 950. And if we come back to this drawing until it's opening, let's define the dimensions. The left inside diameter is 737. Okay, and from the same thing here, it's 737. And for the left face, which is T1, okay, the T1 equals 7 millimeters. Okay, so here we have that value, which is 737, and here that face is 7 millimeters, so it's 7 millimeters and 7 millimeters, and the thickness, which is the thickness at the end here, which is that thickness at the top, which is equal 118 minus 16 and 14, so it will be here the thickness will be 89, and here for the left face raised face diameter, it's 790, sorry, and for the raised face thickness is 8 millimeters and 8 millimeters, and here the bolt circle diameter is 880 millimeters, and for the bolt hole diameter is 33, and the number of bolts is 36. And now the number of passes, let's activate that one and make it with 2 passes, and here define the pass partition, and the fillet will be make it 15, and keep the other dimensions as they are, and from here click on save. Now as you can see here, we defined the dimensions, the main dimensions of this tube sheet, and from the tube bundle we will generate the arrangement of tubes. So from here, let's make an editing on this form and define the shell inside diameter, and the shell thickness is 18, and the clearance, let's make it 10 millimeters, and here the tube outside diameter. So if we take a look to this drawing here, so the tube outside diameter is 19.05 with thickness 2.11. So from here, let's define the tube diameter. Okay, and here the tube clearance, and for here the beach will be 25.5. So if we come back here and check, this detail is 25.4. So let's define the spacing, and here the clearance. And for the top clearance, if we take a look from here, if we measure the value from here to there, for example, here we have, let's say, 110 millimeters around that value. So let's make it to be like that at top and at the bottom. Okay, and for the pass partition, we have two passes, and here the vertical pass lane will equal. So if we come back to the drawing here and check the vertical pass lane, so that value will be 9.58. So let's define 0.58, and the same for the vertical and horizontal pass lane here, and make a symmetrical distribution for holes. And here for the tie rod hole, it will be 12. The tie rod diameter will be 12, and the tie rod hole diameter will be like that. And for we haven't a ceiling rod, so we can keep everything as it is and make all positions with symmetric. So for here for the tie rod position, we can make the depths. So if we take a look here for the depths of the tie rod is with 20 millimeters depth. So we can define this as 20 millimeters depth, and the end will be like that. And for the size will be 12. And for the ceiling rod, we can keep it as it is because we don't have a ceiling rod. And here for the tube layout, as you can see, you can make a selection between a straight hole or a hole with a chamfered end. And now if we come back again to this form and click generate tubes, as you can see here, we can get arrangement for tubes like that. But actually, if we take a look to the tube arrangement, it's 90 degrees. So let's select the square with a 90-degree arrangement, and from here select the big point to be at the center and redraw the arrangement again. Now the vertical bus lane value, we need to redefine it and measure it in a correct way. So let's measure the value from the center here to the center there. It's 25.6. So we need to define this value as 25.6 and 25.6 and draw again. Here we have the modified orientation for this one, and let's take a look for the arrangement of the tubes. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. So here let's check that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to check the that arrangement again. So maybe something not correct in the arrangement. So we need to decrease this value. So let's make it 55 and 55. Something maybe not correct on the scale of this drawing. So let's check the scale. If we measure that value, the diameter of this hole, it's okay. The scale is not correct because here the diameter is 28.58, and here actually the whole diameter is like that. So I think we need here, so let's check the number of rows again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's recalculate that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we need to increase this value a little bit. 65 and increase the clearance and recreate the drawing again. So let's increase the clearance again and recalculate. Okay, now we have this this arrangement. Let's calculate the number of rows: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 rows by that way. Okay, and let's come back to this arrangement again. As you can see here, if we take a look to that view, we have here 4 equal rows, but here we have 3 rows only. So we need to remove one hole from here, or we can use the that OTL instead of the vessel inside the diameter and clearance, so we can directly use that value, which is 327, for example, and make the clearance equal 0 and draw that again. Okay, the tube sheet clearance. So I think we need to redefine that and generate that. And now let's calculate the number of holes per row. Add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And here, if we take a look, it's 26. So I think we need to increase the number to decrease that value. So let's make it 15 and draw. One, two, three, 5, 6, 7. Okay, so as you can see, we make the number of the first row is 28 holes. Okay, so here for the first 3 rows, we have the same number, which is 28, and for the next one, we have 24 holes. And if we take a look here, after 1, 2, 3, 4, 5, 6, so the 7 hole converted to a tie rod. So on the that row, 1, 2, 3, 4, 5, 6, 7. So this one will be a tie rod. As you can see, we converted to a tie rod, and so those rows will be with 3 holes, and for the other for the top one, it will be minus hole. So it will be that one is correct. And now let's remove this hole, and from here remove this one, remove this one, and remove that one. So as you can see here, we removed the top hole from here, which is the hole exists on that area. Okay, and for the second 2 rows, they are the same, so that one and that one is okay. And for the other one is not include a tie rod or a ceiling rod, but here we have removed a hole after 1 to on the 7 vertical row. So same here, we will remove this one. So the same we will do it on the other side. And here on the same row, we will remove this one and remove this one from that one. Okay, now let's go to the tube passes and calculate the number of holes. So in the top side, we have 264, and on the bottom side, it's 264. So 264 by 2, so that's the total number of holes is 528. So if we come back here and calculate or check the number of holes, it's 528 holes. It's the same arrangement of the tubes. Now let's export those information which we generate to SEG. So from here, let's export the information and close this form. Now let's add some attachments like tubes, tie-rods, and baffles for this tube bundle. Now let's read the tube. Okay, and from here, let's select appended tube and define the length. So if we come back to the model here, as I figured, we have 3 different lengths for the tube, but in SEG software, we can define only one length for the tube. So we will select the greater one. So from here, let's define this value. And here the thickness of the tube, and here the offset, which is the offset from the end, which is that value. So we can measure it from here to there. It's 3 millimeters, and it's clear here in this detail. And click on save. Now let's add the tie rod. And for the tie rod, let's define the tie rod length. So from here, let's check this view. So here the tie rod length is 4893. And for the start thread length, which is that length, it's as per this drawing is 60. Okay, and for the nut offset, it's 40 millimeters, and for the thread at the end is 30. Okay, and the tie rod penetration is 20 millimeters, and the nut size is 12. Okay, and that's the nut size. And let's click on save. Okay, and now let's run the add the baffles. So from here, let's add the baffle 1 or baffle A. Okay, and for the baffle A, we will select the segmental baffle, and from here the inside diameter of the can and the baffle height. So if we take a look to the baffle here, that's the cut, and per the definition here, we need the height. So from this drawing, we can calculate the required height by that equation. So that's the inside diameter divided by 2 to get the value from center here to the inside surface of the vessel. And now let's add the that value, which is that value. So that will be the H value. So we can add it right here, and here the spacing between baffles. So if we check that the spacing equals 800 millimeters. So for the typical, it's 800. So it's 800, and the thickness is 8 millimeters, and the clearance will be 2.4. So how to calculate the clearance? Here we have the outside diameter, and here we have the inside diameter of the vessel, negative or minus 735.2. So that's the total clearance divided by 2. So that will be the clearance in a single side. So we will define this value, and the location for the first baffle will be measured from that face. So from here to there, to the center line. So it will be 782. So we will increase above this value, we will increase the facing thickness here. So the location will be 782, and the orientation will be 190 degrees because the cut, because the cut at the bottom. And here we don't have the vent, and the number required of the baffles is 5. Now let's add another baffle, which is baffle B, and we will make it looks like baffle A. Okay, so here. Okay, so from here let's define the height, spacing, and here the thickness. So the location of the first baffle from type B, we will increase here 400 millimeters. So the location will be 1182, and the orientation will be at 0, and for the vent, that's the vent hole, and here the quantity is 5. Now let's add the last baffle, which is baffle C. Okay, and click on add. And for the baffle C, it's an end baffle, so it's a complete baffle. And from here, let's define the inside diameter, and the cut will be equal 0 and 0, and the thickness will be 16 millimeters, and the clearance will be 2.4, and the location as per this drawing, we can measure it from here to there. Okay, so it's 4,832, so the location will be 4,832, and here the no orientation and no spacing, and the vertical vent. I think we need to check if we have a vertical vent or not. No, we have a bottom vent only, so we can make the orientation 180, so the vent will be like that, and no chamfer and no required quantities. Now let's create the assembly. So the first part will be generated, which is the gasketed pass partition, which is that one. After that, the tube sheet, and finally the attachments for this tube sheet, like bended tube, the first bended tube, the tie rod, and the 3 baffles. Okay, here as you can see, we generate the baffles and the tie rods, and I think we may need to increase the nut spacing a little bit, so we can measure that value, so we can inspect and measure the distance between this nut from that surface to that surface and make it 33. Okay, so return back and make a modification here on the tie rod and make the nut offset is 33, and click on save. Now let's update the assembly to update the nut offset. We need to decrease this value a little bit more, so we can measure the distance from here to the face down there, so we can select the suitable face, which is that face. We need 11 millimeters to decrease 11 millimeters from here, so it will be 22, and on the assembly to update the nut. To be like that. So we need to decrease 6 millimeters. So the nut offset will be from here, so be 8. Okay, now it's adjusted. Now to make the pattern of the tubes. Before creating the pattern, I would like to notify for something. Here, as you can see, the tubes is for the first row is crossed. Here in SEG, this option is not an option. So we will generate it as a tube directly from here to there. Okay, from here to there, not from here to there. Okay, so now let's come back here, and for the tube sheet, we will open the tube sheet tooling, and from here, let's click on Start Hauling to start generating the tube pattern arrangement and tube sheet hauling. This process may take several minutes to be generated, so I will keep the machine running this. After that, on the second tutorial, inshallah, we will complete the main equipment items, and we will generate some attachments. Okay, here finally we generate the whole pattern for all elements like tubes, baffles. So if we open the tube bundle, tube sheet, for example, you will find here the tube sheet, including the thyroid holes, as you can see here. Okay, like that. And for the baffles, let's close this. And for the baffles, so let's collapse all children. And for the baffles, here let's open the baffle 1. And here that's the first baffle. And the second baffle, which is baffle B. Okay, here the baffle B with the vent. And finally the baffle C, which is the end baffle. It's like that. And as you can see here, there is one of the tube rows. It's shifted a little bit. That's because the API on the Autodesk Inventor 22 and 21 needs an update. So how to solve this? It's very easy. Now let's go to inside this pattern. Okay, and from here you will find here a driven sketch pattern. All what we need to do, just open this pattern and click OK. Nothing else. So as you can see, it's adjusted automatically. Sometimes if you faced this issue, just open the part and double click on the pattern and it will be adjusted in one time. Here, as you can see, we have the tube bundle assembly. Okay, it will be like that. And on the next part of the tutorial, inshallah, we will discuss how to generate the remaining items for the BEU heat exchanger, and on the next parts we will discuss how to add the attachments like nozzles and another nozzle attached to another nozzle. See you on the next part of this tutorial. Thank you for your time.